Alright, this should be one of the last videos for this chapter. We're skipping section 11.4. We're going to go do 11.1, 2, 3, and then finish with 11.5. And don't forget the test is going to be next long day of next week. First period yours will be Wednesday, and seventh period yours is going to be Thursday. So just keep that in mind. We started binomial theorem in class on Wednesday or Thursday, so I'm going to kind of skip to where we dropped off, and we got to combinations. And remember, the whole point of the binomial theorem is to allow you to expand allow you to expand binomials such as x plus 5 to the 12th power without having to write it out 12 times and do a buttload of FOILing. So a binomial theorem gives you a way to expand that a little bit easily. And we dropped off with doing combinations, which I gave you this formula in class, but remember the n choose j thing, and that's how you read that. That's read n, choose j. You may hear me say n, taken j at a time. That's kind of a long way of saying it, but that's read n, choose j. And there is a formula, and we did that in class, but really we're just going to punch it straight into the calculator. So if you have a TI-89, remember that if you have an expression, say 7, choose 3, and you want to punch that in the calculator, on the TI-89, that's going to be written as NCR. You find NCR in the catalog. And then in the parentheses do 7, 3, and then you'll hit enter and it'll give you the answer. If you have a TI-84 or an 89, the way you're going to punch in 7, choose 3, you still find the NCR command, but before you select it, you have to hit the number 7 first, and then find NCR, then you hit 3 afterwards, and you hit enter. And both of those will give you the answer, and I have my calculator here next to me. I like to find those in the catalog. There are other places in the calculator where you can find these commands, but I'm just going to punch mine in the catalog. And 7 choose 3 is 35, and we're just going to punch these in the calculator. I'm not going to ask you to do the formula, but if your calculator explodes or if somebody catches you off guard this weekend while you're at a party or something and asks you to do combinations, you can do that formula. All right, so expanding these binomials. I gave you a little shortcut that I learned when I was in high school, but it's not in the textbook. What I'm about to show you here is the way we're going to use the actual binomial theorem and these combinations to do the expansion of binomials. We talked about the terms where if it's a plus b to the 6, we said it's going to be some number times, and then it'd be a to the 6, and just for the sake of being showing the whole formula, it's a to the 6, b to the 0, plus some coefficient times, and then your exponents of a go down by 1, while your exponents of b go up by 1. So then it'll be something times, my a will go down by 1, my b will go up by 1. Something times, a to the 3rd, b is going to go up by 1 to 3, plus something times, a to the 2nd, b to the 4th, plus something times a to the 1st, b to the 5th, plus something times a to the 0, b to the 6th. And remember, anything to the 0 power is just 1, so these terms, the b to the 0 and the a to the 0, I'm not going to expect you to write those, but that is technically part of the pattern here. Okay, the way we're going to get the coefficients, I showed you a little shortcut that we did in class, where if you're expanding the whole thing, you can use it, where you multiply the coefficient by the exponent on a and divide by the term number. But another way you could do this is each coefficient is actually a combination. So it's going to be something, choose something, something, choose something. So I'm going to set my parentheses for the combinations. Something, choose something, something, choose something, something, choose something. All right, the top number, and we're doing these combinations like 7, choose 3, the top number is always going to be the same as the original exponent. So all of these are going to be 6, choose something. All of these are 6, choose something. The bottom number, it starts at 0, and then you count your way up. 0, 1, 2, 3, 4, 5, 6. And you simply punch those in one at a time into the calculator. And I'm going to do that real quick. If I did 6, choose 0, that's going to be 1. So this whole thing is going to be 1, a to the 6, and b to the 0 is 1, so I'm not going to write that. 6, choose 1, I've already punched that in the calculator, but 6, choose 1 is equal to 6. A to the 5th, b to the 1st, plus 6, choose 2 is going to be 15. a to the fourth, b to the second, plus, next one's going to be 30. 6 choose 3 is 30, and we're just punching these in the calculator. A cubed b cubed plus 15 a squared b to the fourth, and I just punched in 6 choose 4 to get my 15. And once it starts repeating, I've already started, it goes uphill, then it goes right back down. So I'm starting to repeat. It's 15. My next one, I can look and follow the pattern. It's going to be 6, and a is going to go down, a to the first, b to the fifth, plus, and the last one's going to be 1. A to the 0 is 1, so I'm not going to write that, and it's b to the 6. So that's how we use the combinations to do the binomial expansion. Let's see. So that's that one. Here's another one, x plus 2 to the fifth. When I expand that, I'm going to start by writing out the terms. Now here it's not two variables, it's a constant. It's 2 to the fifth. It's x plus 2 instead of like x plus b or something like that. But it's still going to set up the same way. It's going to be something times x to the fifth, 2 to the 0, plus something times x is go down by 1, and 2 is going to go up by 1. So 2 to the first, plus x, whoops, forgot my blank. X is going to go down by 1, 2 is going to go up by 1, plus something, x is going to go down by 1, 2 is going to go up by 1, plus something, x is going to go down by 1, 2 is going to go, I don't want parentheses, so yeah, dude, 2 is going to go up by 1. And then finally, x is going to go down by 1 to 0, my exponent on 2 is going to go up by 1 to 5. And then we'll fill in the rest of it. My first parentheses, it's the top number is always the same as the original exponent. The bottom number, we start at 0, and then we count our way up. So the next one's going to be 5 choose 1. Next one's going to be 5 choose 2. Next one's going to be 5 choose 3. 5 choose 4. And 5 choose 5. Yeah. Then we'll punch those in. Once we punch those in, 5 choose 0 is 1, so it's going to be 1 times x to the fifth, and 2 to the 0 is just 1. And again, you really don't have to write 1 times x to the fifth, but I'm just going to kind of kill it dead and put the coefficient there. 5 choose 1 is 5, x to the fourth times 2 to the first is just 2, plus 5 choose 2 is going to be 10. X cubed, 2 squared is 4. So 2 squared is 4. Plus 5 choose 3 is going to be 10. X squared, and 2 cubed is 8. Plus 5 choose 4. Oh, I've started to repeat. I've gone up, I've hit 10, now I'm going to go back down. My next one's going to be 5. X to the first, and 2 to the fourth is 16. Plus, and then 1, x to the 0, which is 1, and 2 to the fifth is 32. Then finally, to kill this completely dead, we're going to do the multiplying. 1 times x to the fifth is just x to the fifth. But for every other term, I have 5 times 2. That's actually going to end up being 10 x to the fourth. Plus 10 times 4 is 40 x cubed. Plus 10 times 8 is 80 x squared. Plus 5 times 16 is also 80 x, and 1 times 32 is 32. And that would be your final expanded form. A lot easier than having to write this thing out 5 times and doing a buttload of expanding. If I ask you to expand things completely, I'm actually going to be kind of nice to you. If I ask you to write out the entire expansion, all their 1, 2, 3, 4, 5, 6 terms of this thing, if I ask you to do the entire expansion, I am perfectly okay if you stop right here with this one. I went ahead and cleaned this one up just as an example, but I'm okay if you want to stop with that first one and not finish by multiplying the coefficients. But that's only if I ask you to do the entire expansion. And the reason I'm saying that is another type of problem we're going to do is I'll give you an expansion, a plus 4 to the 12th, but I only want you to give me the fourth term, not the entire term of the entire sequence. So if I only ask for one individual term, then I want it to be completely simplified. And what we're going to do, instead of writing out the whole series and just counting to the fourth term, we can actually kind of skip, not kind of, we will skip straight to the fourth term, following some patterns here. And if you notice, the coefficients are always 5, choose something. The original exponent, choose something, starting with 0 and counting my way up. If you notice, this is my first term. The number on bottom is 0. It's 1 less than the term number. This is my second term, so it was 5, choose 1. My third term was 5, choose 2. My fourth term was 5, choose 3. The number on bottom is always 1 less than whatever term number it is. Also, something else you may notice is that the number on bottom is also the same as the exponent on the second term. 5, choose 4 is the same as the exponent on 2. And that pattern was true over here also. When I did 6, choose 3, that number on bottom was the same as the exponent on B. 6, choose 5, the number was the same as the exponent on 5. So there's a few patterns there that's going to help us jump straight to, on this one, the fourth term. How much time have I spent? 10 minutes. Okay. So if I want to go straight to the fourth term, I'm not going to write every single term up to the fourth term. I know I'm going to have some coefficient, and then I know I'm going to have a to some exponent, so I'm going to put a little box here. So I'm going to have some exponent on a, and then I'm also going to have some exponent on 4. So it's 4 to some power. So I'm going to have to find an exponent for 4 also. And the coefficient, I know it has to be, stupid dots. My coefficient is going to be 12, the original exponent, choose something. And what you need to remember is that the number on bottom is the same as the exponent on 4. So I'll use a little green box. If I could find out any of these numbers, then I could trickle on down to the rest of it. And this is going to be the fourth term. And what I remember is my term numbers, my fourth term, the bottom number is always 1 less. It's going to be 3. If I asked you for the third term, then the bottom number would be 2. So right here, I'm asking you for the fourth term. That means this number has to be 3. And I use the number, since it's the fourth term, I use that to determine that that number is going to be 3. This number is always the same as this number. The number on bottom is always the same as the exponent on 4. Now we've got to figure out the exponent on a, and this is something that I forgot to point out on the previous page, but these two exponents together will always add to the original exponent. If you look at all these exponents, 4 plus 1 is 5. 3 plus 2 is 5. 1 plus 4 is 5. 0 plus 5. The exponents on your two terms always adds up to the original amount. So these two numbers, the number on bottom here and that number is the same, and these two numbers right here must add to be the original exponent. So if that's 3 and they have to add up to 12, then this number has to be 9. And so now I actually have the whole formula for my fourth term, and we'll go to the calculator. I'm going to punch in 12, choose 3. So 12, choose 3, punch that in, and you get 220 times a to the 9th. Can't really do anything with a to the 9th. 4 to the 3rd, punch that in the calculator. That's 64. And right here, since I did ask you for only one term, I only want the fourth term, go ahead and finish this out. Kill it dead. 220 times 64, 220 times 64, punch that in the calculator, and you get 1,480, or 14,080, a to the 9th, and that is going to be the fourth term of this expansion. You don't have to write out the whole thing. You can jump straight to whatever term is requested. See, the coefficient of x cubed, we're going to go a little bit quicker now. The coefficient of x cubed, again, I'm only wanting one term, so I'm going to have some coefficient. I'm going to have x to some power. And also, this is x minus 3, so your second term is actually negative 3. And then what I've got to find now is the exponents. I'm going to have some exponent on x. I'm going to have some exponent on 3. And then I need to do something, choose something for my initial coefficient. I know it's going to be 9, choose something. That's my original exponent. So 9, choose. Now, if I want x cubed, I want the coefficient of x cubed. Well, that's going to help me out a lot, because if I want x cubed, then I know I need x cubed. Once I can get one of these exponents, the rest of it trickles into place, because I know these two have to add up to 9. So 3, this one's going to have to be 6. And if that's 6, then I know the bottom number over here has to be 6 also. They're always equal. And then we'll go straight to the calculator. So our calculator, come on, don't fail me here. So I need to do 9, choose 6. 9, choose 6 is 84. times x cubed. And negative 3 to the 6 is 729. And then we'll multiply 84 times 729. We get 61,236 x cubed. And if you stop right here, that's fine. Technically, since I asked for the coefficient, your answer is just 61,236 because all I asked for was the coefficient of x cubed. But if you gave me this answer, I'm perfectly okay with that also. All right, last one, the coefficient of x to the fifth. In this expansion, exact same kind of question. I know I'm going to have some initial coefficient, which will be something, choose something. Now my first term is actually 2x. We have to trap that whole thing. It's going to be 2x all to some power. So I'll leave a little empty spot for an exponent. And then I need plus 3, so my second term is a positive 3. I need to find some exponent for it also. And we are looking for the coefficient of x to the fifth. So if I need x to the fifth, then I need to raise my x term to the fifth power, and everything trickles down from there. They have to add up to be 9. 5 plus 4 is going to give me 9. I know the exponent on my second term is the same as the bottom number over here, and my top number is always the same as the original exponent. So now I have everything set up. Punch in 9, choose 4. Punch in 9, choose 4. And you get 126. Okay. Now 2x to the fifth, you have to do 2 to the fifth also. So 2 to the fifth is 32. X to the fifth. And 3 to the fourth is 81. And then we have to multiply all that together. 125 times, or 126 times 32 times 81. 326,592. And we will get some big numbers. We'll get some that are a lot bigger than this also. So 326,592, x to the fifth. And I asked for the coefficient of x to the fifth. So after I cleaned up, the coefficient was 32 per 326,592. There we go. And man, it still went long. I've got to find a way to cut this stuff down or be more entertaining. Maybe I could sing a song. I don't know. All right, so there we go. Answer the quiz. There'll be 3 or 4 questions. I hadn't made it yet. Hadn't decided. And help your mom unload the dishwasher this weekend. I'll see y'all later.